Alright, so this one's asking to find which point lies on the line of the solution, or lies on the solution in the solution set for the system. So we have a system of inequalities, but whether it's inequalities or equations, if you remember what it means to lie in the solution set, or if it's a point, meaning if it's a solution, is if I substitute it in or if I plug it in, it works. That's all it means. So it has to be something that's true when I plug it in. So let's just go through each one of them and plug them in and see which one works. So let's start with this one. Negative 3 for x and 3 for y. So make sure you remember that. It's x comma y. So I'll plug it into the first one. It has to work for both, so let's make sure we check both. I have 3 times x, which we see as negative 3, minus 9 times y, which is 3. This is less than negative 7. And let's see if this is true. So I get negative 9 minus 27 is less than negative 7, which is negative 36 is less than negative 7. Well, if I were to graph this, yes, this is further to the left on the number line, so it is less than negative 7. Now we have to check the second one, because it's not good just to put it on 1, so this one's okay. And let's do the next one. So I'm going to plug in 3 times x, which is negative 3 again, plus 2 times y, which is positive 3. And we want this to be greater than 6. So I get, this is going to be negative 9 plus 6 is greater than 6. And I say negative 3 is greater than 6. Now this is not true. Negative 3 is less than 6. So this one did not work. So since it did not work for both, A is not the answer. So we'll move on to B. And let's see if that one works. So let's try B. I'll do this over here now. So B is negative 1 and 2 for x, or negative 1x for x, negative 2 for y. So let's plug that in. 3 times negative 1 minus 9 times negative 2 is less than negative 7. And see what we get here. We get minus 3. Negative 9 times negative 2 is positive 18 is less than negative 7. And I get 15 is less than negative 7. So that's not true. So this one doesn't work either. Next, let's go look at 9 comma 3. So let's try this out. So I'm going to plug in 9 for x. So it's 3 times 9 minus 9 times 3 for y. And I get 27 minus 27 is less than negative 7. And at 0 is less than negative 7. So that doesn't work either, so it must not be this. Answer must be D, but let's just make sure we show the work for that. So to show for D, so on your paper this is the only one. You probably need to copy the other ones. You don't need to. Let's plug that in. 3 times 5 for x minus 9 times 3 for y is less than negative 7. So I get 15 minus 27 is less than negative 7. And 15, I get 2, negative 12 is less than negative 7. So that one's true, like we expected. Now let's double check that it works for the other one. So I have, so this one's good. Now let's check this one. 3 times 5 again, plus 2 times 3 for the y is going to be greater than 6. And here I got 15 plus 6 is greater than 6. Well, definitely 21 is greater than 6. So it works for both. So our answer is going to be D. Number 27. So we want to graph the point that shows the location of this. So we need to find the imaginary number. So before we get our complex number, before we get this complex number, we have to actually subtract these two complex numbers first. But it's really easy to subtract. All we do is combine like terms, basically. Add together the real parts and add together the imaginary parts. But it's subtraction, so we just subtract them. So if you remember, for subtraction, it's probably easier if we just add the opposites. So it's plus, and then make these all opposites. Oops. Minus and minus. So if I add together the real part, which is negative 5 and negative 1, that's negative 6. The imaginary part is 2 and minus 6 is minus 4. And how do we graph this? Well, remember, this is the real part. This is the imaginary part. And if you notice on the graph here, this does not say x-axis, y-axis. It says real axis, imaginary axis. So on the real axis, we should get minus 6, which is 1, 2, 3, 4, 5, 6. Then the imaginary axis, or like the y, is like a minus 4. So I'm just going to go down from there, 1, 2, 3, 4. So that's my solution, which is letter A. For number 28, this one, remember when we want to simplify this, we want to find things that are to the 4th power to take out. Or basically we're finding groups of 4. So let's just go ahead and split this up. I know 32, for example, could be written as 8 and 4, which this is 2 times 2 times 2, and then that 4 is more 2's. And I can see, okay, there's a group of 4 2's, so that can go on the outside. Now this 2 is going to be left inside, but let's look at all the other ones first. Out of x to the 6th, I can make one group of 4. There'll be 2 left over inside. Y to the 8th, I can make 2 groups of 4, so that's y to the 4th, y to the 4th. If I take the 4th root, we'll get 2 y's on the outside. Same thing here, z to the 9th, I can make 2 z groups of 4. And left inside of the root, make sure we put the little 4 on there, we had a leftover 2. We had 2 leftover x's, so that's x squared. And we had no leftover y's, all of them came out. And then 1 leftover z. So we have 2x y to the squared, z squared. Which one is that? That would be this, A. All right, number 29. Before I can do my addition or subtraction, we have to distribute the 2, or the minus 2, should I say. And let's go ahead and do that, and then we'll be able to combine like terms. So all we do here is the first one is still 2x squared minus x plus 6. But after I distribute the minus 2, it's going to be plus minus 4x squared plus 4x. And then negative 2 times 4 is minus 8. Now we can just combine like terms. So let's start off with the x squareds. So I have 2 and negative 4x squared is negative 2x squared. I have minus x and plus 4x, that's plus 3x. And 6 minus 8, that's minus 2, which the answer would be D. And the last problem here is to find the ordered pair for the vertex. And if you recall what a vertex formula is going to be opposite b over 2a, that first part of the quadratic formula. So again, our a is 1, our b is 4, and our c is 3. So let's go ahead and find the x value of our vertex, which is opposite of b, negative 4, over 2 times a. And here I get negative 4 divided by 2 is negative 2. So I know my x value is negative 2, so it's not this one, it's not this one. Now we just have to find the y, which all we do is plug it in. So y is equal to x squared plus 4x plus 3, but instead of an x, we're going to use minus 2, because that's the value of x at the vertex. So minus 2 squared plus 4 times x again, which is minus 2 plus 3. And be careful here, negative times a negative is positive 4. Here I get minus 8 plus 3. And so my y value is negative 4 plus 3 is negative 1. So my vertex is going to be negative 2 for x, negative 1 for y, which is A.